Good morning, good afternoon, good evening, whenever it is you're watching. Welcome back to Artisan Electrics. Thanks for watching. If you're new here, welcome. And if you're not new, awesome, welcome back. If you haven't done so already, hit that subscribe button, hit the like button, and don't forget to tap the notification bell, especially if you're an existing subscriber but you've not tapped that notification bell. Do so, and then you get notified every time I post a new video, and it really helps the channel to grow. So today I've got an EICR for a HMO, a house of multiple occupation to do. It's a 4-bedroom house. The council are coming around to do an inspection soon and they needed an EICR doing. So what I'm going to try and do is walk you through it step by step, show you some of the things that I find. I have no idea what I'm going to find, whether it's going to be good or bad. I have a feeling it's going to be bad, but we'll see. What I'll try and do is show you some of the defects if I find them. And maybe we'll play a little game of code it, and you can let me know in the comments how you would code that particular defect, and then I'll show you how I would code it. So I hope you enjoyed this video, and let's get into it. Right, so we've got a BG metal consumer unit here. It's an RCBO consumer unit, and it looks like it was actually inspected already in 2017, probably when the consumer unit was changed. So the letting agent hasn't told me about any existing certificates, so I don't have any records of the installation, but at least it's all labelled up. So we've got circuit 1 cooker, circuit 2 water heater, circuit 3 sockets, circuit 4 sockets. Interestingly, they're both 16 amp radials. Then you've got circuit 5 smoke detectors, circuit 6 lights. It looks like we do have main bonding present. It's a TNS system, which means the earth is coming off the sheath of the supplier's cable here and going to the main earth terminal. Then it looks like we've got an earth cable going down here. I'm not sure what that's going to. Looks like a 16 mil. Then we've got 2 6 mils coming off here. Then we've got another 6 mil coming across to the consumer unit. So the cable entry holes are sealed with a fireproof plug, which is good. 16 mil tails here coming from the meter, and we don't know the supplier's cutout fuse size because it's one of those old ones that's not labelled. But I'm assuming it's a 60 amp as it's 16 mil tails. We'll have to put that as a limitation on the report. And the outgoing cables come out of the top of the consumer unit, but it is IPXXB. It's nicely sealed around the cables. There's no other knockouts there. This screw is a bit loose, which is not great. So the lid can actually pull off slightly. So we need to have a look at that. That's about it for observations in the consumer unit cabinet. I'm going to take the lid off and see what it looks like inside. So it's fairly neat. You can see they haven't done too bad of a job. We've got the old BG full-size RCBOs here with the functional earth tails. You can see those are the white wires there. Busbar cover is on. I'm not sure what's going on with this screw. It looks like it was just left unscrewed. There doesn't look to be anything wrong with that. So that's fine. What I'm going to do is go over the board with my torque screwdriver and just check the torque settings are correct on all of the terminal screws for the circuit breakers, the neutral bar and the earth bar. So I've got my TIS earth leakage clamp meter here, and what I'm going to do is just take an earth leakage measurement for the installation by clamping across the phase and neutral conductors. And there we've got nothing at the moment. If I take the scale down slightly, you can see we've actually got 7.5 milliamps of earth leakage going on in the system, which is within tolerance. So it's probably electronic devices which are connected which are causing a small amount of earth leakage. But because we've got a 30 milliamp RCBOs on each circuit, that also helps with the earth leakage because we've got a tolerance of about 15 milliamps per circuit, so we're well within that. These RCBOs are just type A, which is not ideal really. Nowadays I would only fit type, these are type AC, I would only fit type A, but they're perfectly acceptable anyway and they'll do the trick. So here's an interesting one for you. Pull switch, the cord doesn't have an insulating piece in it. Obviously the insulating piece is broken, and so they've just tied it together here, but actually that's not acceptable because the insulation piece is designed to, if there was a problem and the switch got wet, the cord is wet, the insulating piece would stop the moisture in the pull cord from conducting electricity when someone pulls on the handle here. So actually that needs a new pull cord putting in with an insulating piece, or just an insulating piece fitting to it. Now how would you code that? I have no idea really, because I think it's very unlikely to cause any problems, but doesn't comply with the regulations, doesn't comply with manufacturer's instructions, something like that, probably a C3. So we've got a bathroom light here which is actually loose, it's not fixed properly, so that could ideally do with replacing really with a LED fitting. So I will make a recommendation about that. How would you code that? Let me know in the comments. So we've got the same issue here with the insulating piece having been overridden, shall we say. Basically, again, the pull cord has snapped, which is classic on these. They just get tired after a while and they break, and then they've just tied a new pull cord on, but the insulating piece isn't in place, so I would recommend replacing that and putting a new insulating piece on. We've got another one of these lights here, and again, it's not really fixed solidly to the ceiling, so I'd recommend replacement of that light fitting. We do have mains powered smoke alarms here, which is required in HMOs, and the replacement date is 2025, so they're still within date. This is something that's important to always check, is that the smoke alarms are in date, because they do have an expiry of 10 years after installation. They're not designed to be used for any longer than that, so if they have expired then they do need to be replaced. So this is the kind of thing that we see a lot in rental properties, and it's lots of extension leads being used because of an inadequate number of socket outlets. Excessive use of extension leads can lead to overloading and can end up causing electrical fires. So if there are a lot of extension leads, then we do recommend increasing the number of socket outlets in order to alleviate the use of extension leads and splitter cables. Again, we've got the same scenario here. It's only a single socket, so they've run in a splitter cable for that. But it seems like in this whole bedroom there's only one single and one double socket, which for modern requirements is not really satisfactory for what people need with all the gadgets and things that they tend to plug in these days. There is another single socket on the other side of the bed, which could be converted to a double socket in order to create more outlets. So this is one of the pendant lights, and they're these kind of bizarre pendants that have got a connector block in them. Not the greatest really, and the flex goes in the side, and the cover doesn't fit on very well because of the flex going in the side, so it's all a bit strange and I don't really like these. I would probably recommend replacing them with new pendants because these are quite old and not really very well fixed to the ceiling. So this is something that you'll see in a lot of HMOs. They do have to have fire doors on the bedrooms. So in this case, we've got fire doors, we've got closers, we've got fire seals which have to be done properly, and these kind of catches which can be unlocked from the outside and which just slam shut. That's very important for a HMO to have those in order to comply with fire regulations, and the doors should close by themselves like that and be fully sealed against fire without anyone having to pull them shut. So this is not really an EICR thing, but it's just an observation I'm making now, is that this fire door is not really hung properly, and so it doesn't actually close by itself, which means the fire could spread into that room quite easily. So I will make a note of that and send it to the letting agents so that they know that that needs to be sorted out. I don't know why it's like that, maybe it's just come off its hinges slightly, but definitely needs sorting. Yeah, so it looks like actually the hinge here has started to come away from the door frame, and that's why it doesn't close properly. It does with a bit of a push, but it's not ideal. So that just needs tightening up properly and hinging properly. So we've got a bizarre kind of wall light set up here, no ceiling light, wall light, light switch here, but there's also a pull switch for that wall light, but they've wrapped the pull cord around the light. Funny. Okay, so obviously not using the pull cord. Question is, does it work? And the answer is yes, it does. But it's a bit pointless. I mean, that's a classic old school type thing that they used to do. Basically, when they had the bed, then you would, turn the light on as you come into the room, then you get into bed, and then you pull the pull cord to turn the light off. But people don't really do that anymore. I don't know why, it's just gone out of fashion. But that switch actually looks like it's hanging off the wall, off the ceiling a bit. It's not properly fixed, so I might recommend just getting rid of that. So I'm not quite sure how I'm supposed to actually inspect anything in this room. It's just absolutely full of junk. It's disgusting the way people can live, to be honest. It makes me sick. I don't know how anyone can live like this. Yeah, so I don't know if there's any socket outlets visible, but I don't even want to go trampling on all of this. So this is where limitations come into play. I might just put a limitation on it saying I could not inspect socket outlets in bedroom 4 or whatever it is due to lack of access, and yeah, that will cover me. This light is not in the middle of the room. Not quite sure why that is. It's not even, well, it's just near the window, I guess. So they've done it the old school way of putting the light near the window. Let me know in the comments why, if you know why people used to put pendant lights near windows rather than in the middle of the room. I think I know why, but I'd love to hear from you guys if you know. Now, the fact that we have a water heater switch here and a loft hatch key next to it indicates to me that somewhere up in the loft there is a immersion heater. So I'm going to get up in the loft and have a look, see what I can find up there. Alright, so what have we got up here? As expected, we have a water tank with a switch fuse connection unit, wiring centre for the central heating, motorised valve, pump there, expansion vessel. So there's the tank thermostat. So it doesn't look, oh yeah, look, there is an immersion heater as well. There was an immersion heater, but it's actually not wired up. There's no cable going into it. So probably they just disconnected it when they put the boiler in. Is there anything else? So I can see cables clipped around here. We do have a loft light. So let's check if that works. It's not working. The bulb, well, the whole thing looks a bit dodgy. And there's also some kind of funny connection for a TV cable. So let's zoom in and have a look at that. Okay, so I'm up here now. It's nice to have a nice, clear, empty loft. It's quite a rare treat, really. So there's not a lot going on here, just some old carpet and bits and pieces. But we've got here this light. So the switch is not working. The back box has just been screwed down onto the cable there instead of coming out of the knockout. Cable's just loose like this. And look at that. Everything's just loose. I'm assuming this is live, so I'm not going to stick my fingers in it, but all looks a bit dodgy. And then here, how about that for a coax connection? So, never seen it done that way before. That is very interesting. So that comes from the main aerial, I presume. Oh look, there's another one over there as well, another connector. And then there's two cables actually out of that connector which go through the wall, presumably to the TV aerial which is mounted on the other side of the wall. Again, not something we would mention on the EICR, but it's a little indication that maybe some DIY work has been done here, which tells us what the electrics might be like, so it's worth noting. I'm going to do a test on this point to check out the boiler wiring, so I can do a continuity test here and earth loop impedance at this point. Not sure if it's on its own dedicated circuit. It might be. I can't remember what it said at the board, so we'll check that out. So just taking a look at one of these pendants here. You can see you've got 3 plated, so we've got pendant lives in the middle, neutral on one side, switch line on the other side. Looks like the polarity's wrong because they've connected the brown wire into the neutral block on this side, and they've connected the blue wire into the switch live on the other side. Not really a big deal because it's a bayonet connection, but still, it's not how it should be. So in here we've got recessed downlights that have been fitted into holes that are actually too big for them. So they're barely holding into the holes. In fact, this one has gone all the way in. I'm not quite sure what happened there. It looks like they've probably taken the old ones out, which were slightly larger, and put these new LED ones in, which just don't fit properly. So again, question mark over if it's a DIY jobby. So lovely bit of work here. We've got this beautifully painted camouflaged twin and earth cable. Looks like 2.5 twin and earth going to this light. This is outside, by the way, under a bit of a roof, but not much of a roof. Surface box here, and then lovely bit of 0.5 flex, nicely clipped up to a beautiful quality LED under unit light, which does work. The switch is a bit gammy because it's probably got loads of moisture gone in it, and it's been painted. So yeah, how would you code that one? There's also a nice wall light here. Let's take a look at that. Okay, so again, not really IP rated. It's full of spiders webs and rust. Where's it been wired from? No idea. This is TV cabling. So in terms of the rest of the house, there's nothing outside that I can see, which I'm relieved about. I'm going to check in the shed and see if there's any power to the shed. Oh wait, what's this? Oh, there's another lovely TV connection here, look. Nice coax junction box there just outside. So we've got a shed here. Oh, interesting. Main isolator. I hope not. Right, there's no, that's locked. I'm guessing they borrowed that door from some kind of commercial premises, but I'm going to need to check in there just to make sure there's no electrics in there. So we do have a twin and earth cable coming out of the wall here behind that guttering. I'm running down here and then running, it looks like running along the fence. So it could be that it's clipped along and it actually goes into that shed. So I'm going to have to check that. So we've got the gas meter here. And underneath you can see there is a green yellow 6mm cable going up into it, coming through this air vent and just sort of slung in. So I'm going to check inside the meter box and see if it's clamped on properly. Okay, so here it is. Let's zoom in. So we do have a clamp on here, but there's no warning label on it. Electrical earth connection, do not remove, and the wires there are a little bit splaying out from the thing. Not great, so probably worth redoing that connection with a new clamp because it's a bit corroded as well. Also, just a comment here, I don't think I've ever seen a gas meter box that wasn't broken. Like literally every gas meter box that I see, this happens. The whole thing just falls out because the catch breaks. So maybe a redesign is needed. Just a thought to the gas gods out there, whoever designs these boxes, maybe a redesign is in order. So we've got our main bonding to the water here. Again, not the best of bonding connections, but there is one there. However, it is a PVC pipe, so it doesn't technically need bonding anyway now. So not too worried about that one. So the extra 16mm bonding conductor, which was going off from the main earth terminal up there, is actually going to here, and it's an old capped off steel gas pipe. So that has been bonded. It's a fairly, just about to say it's a fairly solid connection, but I don't think you would call that a fairly solid connection, so I'm going to need to redo that as well. Under here we do have these kind of fireproof grommet things supplied by Whisker, I think they are. This one though has been cut out a bit too far, and so it's not that well sealed. Now, to be honest, I would always provide compression glands, not these things, because you can pull on the cables and they're not going to provide any kind of strain relief. So again, it's not a major thing, but I'd pick up on that and just say compression glands would be recommended. Now this is a bit of a funny old thing. You've got this 4-way splitter here, which cable's clipped down along here, and then it goes through the wall to a fused connection unit here. No idea why. Maybe that used to be a single socket and they decided they wanted a 4-way splitter there, but what on earth they wanted that for, I have no idea. Or old single socket that they've turned into a fused connection unit. and decided to run that splitter off. No idea why. So I'm going to take this off and do a visual inspection of it, but first I just wanted to note on this, look, the old flex outlet which is not used anymore, and possible access to live parts. I mean, I can stick my screwdriver quite far in there, so that's something that is not ideal and needs to be noted. So this is basically just acting as a junction box. Now the cables, you've got one in and one out, but they're actually both going into the incoming side of the switch, so it's not actually switching anything on and off, it's just basically joining those two cables together. One of them presumably goes up into the loft to provide power to something in the loft, and possibly the switch fuse connection unit for the central heating system. So I'm going to go and check that. So I've just taken this two-way light switch for up and down stairs off. So you've got a 3-core unearthed cable going down and then twin unearthed cable going up. No identification on the yellow, blue and black conductors to say that they are actually line conductors. Apart from that, it's a bit tight, but nothing really wrong with it. Now, would you code the lack of identification on the line conductors or not? And if you would code it, what would you code it as? So I've taken off the pull switch in the bathroom. Again, no identification of line conductor, switch line conductor in here, and also the earth wire is not sleeved. So again, not great, it's a bit of a mess, but would you code it or not? And if you would, what would you code it as? Now we see these kind of light fittings quite a lot in bathrooms, but I have a question as to whether these are really IP rated, because they're just rubbish. I mean, there's so many holes in the back of that where moisture could get in. If you spray that with a shower head, I'm not very confident that the water will not get in. It doesn't have any markings on it to say what IP rating it is, so I would recommend replacement. And definitely anyway, as it's so loose, it needs replacing. So I've got a socket outlet off here. Check the connections, they are tight. Looks okay actually, nothing, no major issues there that I can see, so that's good. Live conductors are in the live, neutral in the neutral, CPC in the CPC, and they are connected in properly. So I've taken one of these smoke alarms off just to have a look at, see how they've been done, and they look like they've been done fairly decently. Only thing I can see is no identification on the neutral and the interconnection conductor, so that's something that I would improve on, but nothing major apart from that. This looks like it might be the end of line for the smoke alarm, so I'm going to leave this one off and do an earth loop impedance test here later on. So this one's got DIY written all over it again. You've got a black conductor going into the live terminal, the earth sort of dodgily connected on there, and then a brown conductor going into the neutral terminal. And then let's see, oh okay, so bearing in mind this is an Edison screw fitting, the central pin is actually connected to the neutral conductor, and the side piece is connected to the live conductor, which means that the polarity is wrong on this. Also no earth sleeving on there, and it just looks like it's been really smashed in, so I'm going to have to make a note about that as the polarity is incorrect. That's certainly something that needs to be rectified. Let me know how you would code it in the comments. Now when doing an EICR, I don't take off every single socket. Generally I take off about 10 to 20% of the accessories, but when I see something like this, it rings alarm bells and I usually will take it off. So can you see the rust on there and on there? So it seems like maybe some damp has been getting into this wall and causing the back box and the screws to rust. So I'm going to take this one off and see what's going on behind. Okay, so I was right about the screws, they're really rusty. Doesn't look too bad in here. There's not really any moisture. Some of the screws have got a little bit rusty, but it's not as bad as I expected. However, can you see that at the base of the socket? It appears they've brought the cables up in the middle of the box, and so I had to sort of splay them apart, and they've not got grommets in the back box, so there is a very high risk that at some point those wires are going to just get sheared by the metal back box and end up shorting out against the metal back box, which is not great. So we've got a metal light switch here, but the earth is not connected to the front plate. The back box is earthed, so the front plate will get earthed through the screws, but I still should have a little flying lead to connect the front. So there's a switch fuse connection unit here which does the washing machine. That does work, so we'll check behind that and see how they've wired it. Okay, so again we've got a lack of sleeving on the CPC conductors. Looks like the load and supply sides are connected in the right way, so that's good. I'm going to check the connections on there and see how tight they are. So for these lights we've got a junction box here. It looks like, if you can just see there on the ceiling, maybe there was a central light in here before, and they've basically taken the cable from that, run it to a junction box, and then run flexes between all the cables. Now these are actually quite nice lights. These are all LED lights. They are fire rated with proper LED drivers and everything, and the drivers seem to have been wired up fairly well, but the fire rating is kind of pointless when the holes are too big for the fittings. So I've got my long wander lead now here, and I'm going to do some R2 testing. But first I'm just going to zero out my leads. So there we go. So when doing the R2 test, this switch doesn't have any earth continuity, so I'm going to take it off and have a look. So taking the cover off, and this is what we found. So that's why the box is not earthed. They've just twisted these together, but they've not connected them to the back box. So that's going to need sorting out. Bit blackened there as well, so I don't know if there's been some kind of sparking going on, but I mean the whole thing, they've just drilled a hole in the back of this back box and it's sharp as anything. So I've rectified that straight away. I've just managed to stretch it across and put it into the earth terminal on the back box there, so at least that's earthed now. So when I've tested R2 to this point, there's no earth to this point either, so presumably there's another junction box somewhere around here that's got a loose earth wire in it. Now it doesn't really matter because these are class 2 drivers, so the light fittings don't actually need an earth, but still the cabling should be protected by its own circuit protective conductor within the cable, so I'm going to try and find out where the break is. So I've got all these downlights down now, and it appears that there is a junction box in the ceiling somewhere, but I can't find it. There's a twin and earth there feeding, and there's a twin and earth there, and those two are not just connecting between each other. Basically it looks like the junction box feeds to one side and the other side, and then they go in and out like that, because you've got your end of lines here So the cables go basically from the junction box somewhere up here to that one, then to that one, then to that one, and same from the junction box to that one into twin and earth, and then to that one and to that one. So somewhere up here is the junction box. I can't find it, so I'm just going to have to mark it down on the report. Here's an interesting one for you. It looks like CJR plumber has been up to his own electrics again. Upside down thermostat. How on earth is that supposed to work? Great fun. So I've got a very high reading of 10.9 ohms for earth loop impedance on this socket. So I'm going to just swap across to the other side, do the test again and see if it's maybe the actual outlet rather than the wiring itself that's causing the problem. I always note with these that they are heavily loaded because you've got the toaster and kettle on this socket, so it could well be that the socket's been overloaded and it's overheated. 10.75, yeah, so I'm going to take the cover off this and have a look. Before I took that one off, I thought I'd just check actually one of the other sockets as well, and I've got the same 10.72 on this one, so it seems like it might be the actual circuit which has got an issue. I'm going to check this one as well. Taking a long time. Yeah. So somewhere there's a dodgy earth connection. So I'm going to do a functional RCD test now while I'm turning all of these off, so we'll just check those one by one. Okay, we have a dodgy one. That one, okay, so let's check that, turn it off, turn it back on again. Still dodgy. Okay, so that's going to need replacing. That's for the water heater, I believe. Main switch off. Going to disconnect the main earthing conductor and then do true ZE. See what reading we get, because I've got a feeling those high readings on the sockets are actually because there's a high reading on the supplier's earth and we've got high ZE, so I'm going to check that. So what I've done is very, very carefully I've just unscrewed this terminal from the main clamp for the earth. I wouldn't usually recommend to do that because they're very fragile, these things, but this was already quite loose, so it was really easy to just pull those conductors out. And now I'm going to do a high current earth loop impedance test to check my ZE, and I've got 2.33, 2.36, which is way too high for a ZE for a TNS system. So there is obviously a problem on the supplier's cable. And it's funny because I did an EICR literally on the other side of the road from here, and the problem was exactly the same, and it was a looped supply in the house next door where they hadn't connected the earths across the two cables. So the DNO, basically you had two cables, one coming in, one going out next door, two cable clamps, but they hadn't linked in between them, so there was no earth getting across from one supply cable to the other, which then went to the property. And I have a feeling that probably we've got the same issue here. So I'm going to have to contact the DNO and get them to come out and have a look at it And I bet that they'll find exactly the same thing here, which means that probably these properties have been like this for a long time. So I've connected those back in now, and I'm going to do ZDB and PFC tests here and just see what we get with all the bonding conductors connected in. So we've got 2.4 ohms now for ZDB and 103 amps prospective fault current. I'll do a live to neutral as well. So we've got 0.34 ohms, 729 amps, or 0.72 kA for PFC, prospective fault current. So yeah, DNO phone call is going to have to happen now. So now, old chap, I'm going to do a spot of insulation resistance testing, as they say. And I will be using my Fluke 1664 FC to test insulation resistance between the various conductors, phase to earth, neutral to earth, and phase to neutral, using the resistance insulation, so high resistance test function. And I'm going to stick this somewhere where it gives me a bit better light. Something like that. And I'm just going to start by testing all of the phase conductors down to earth one by one. I'm testing at 250 volts just in case there's something connected. Don't want to risk blowing anything up. And I'll start with the first circuit. And we've got 200 megohms, and then neutral to earth 200 as well. Second circuit, phase to earth, or CPC 200 megohms, neutral to earth 200 megohms. Third circuit, which is sockets, 200 megohms, 200 megohms. Good. Okay, so insulation readings are all clear. So now I'm going to do some RCD tests. So I set my tester to the RCD time setting on auto, 30 milliamp, or RCD type A, C, and I'll start with the first one and work my way along. So,
I didn't catch that. Could you try again?
Go away, Siri. Okay. So we've got 0 degrees, all above 200. And then for S1 times, we've got 18.2, 28.2, 18.2, 28.2. Good. Next circuit. So this is the one that wouldn't trip when I press the test button, and it's still not tripping when it should. So it doesn't work at all. So we're going to need to replace that RCBO. Next. 28. Okay, so all RCBOs are good apart from that one. So now to do earth loop impedance tests. So I'm going to start with these sockets simply because the lady's trying to work online, and the sooner I get her internet back on, the happier she will be. So I've already done some sockets which we had high readings on, but probably that's just due to the unfortunate high ZE. Yeah, so this one's pretty high as well, 9.96. Now 2 point something for ZE minus 9.96, that still gives us like a 7 ohms R1 and R2, which doesn't sound quite right to me, but I'm guessing it's just due to the ZE reading rather than because we had quite low R2 readings. So I don't see how the R1 readings would all be mega high. We've tested all these kitchen sockets, so that's good. Let's test a couple of these sockets. Oh, lovely. Jackpot. So we've got reverse polarity on this one. So yeah, another DIY bodge, no doubt. This is why it's important to actually do a test at every single socket if possible, because you never know whether some might have reverse polarity. So I'm going to whip this off and take a look. So there's a classic for you. How bad can you get? Literally somebody couldn't read when they connected that up because they've connected the phase conductor in the neutral terminal and the neutral into the live terminal. So the other thing is here, the back box is broken. I don't know if you can see that, it's completely smashed out. So some little toddler could literally stick their fingers up into that and get themselves a nice shock. So we're going to have to replace that socket and back box and swap polarity back to its correct configuration. So I've put a new back box on here now. That's all proper, and I've corrected the polarity on this socket, so that can be fixed back, and that's made safe straight away. Continuing with the earth loop impedance tests. Let's see what we've got at this one. I've got a feeling this is the spur for the outside power to the shed, so we're going to have to check that out in a minute. Yep, still high. So it looks like that is a new socket with the new circuit cabling, and then it goes around through the wall here behind the units and probably runs this socket so that both fridges actually have power. So no, that one's still long. Yes, it's doing this socket, but it's not doing that socket. So it seems like that one circuit is literally just doing the socket behind the fridge here and that socket there. Must have been a new addition at some point. I suppose it makes sense because there's quite a lot of load for the kettle, toaster and fridge together. That's already going to be close to 16 amps if everything's running together, so it makes sense that they put that on their own circuit, especially as the other circuit, which was probably a ring in the past, but when they changed the consumer unit they probably found that it was actually a broken ring. They had to downgrade that to 16 amps, so the whole rest of the house is on one 16 amp circuit effectively, so there's no way that putting that on it as well would have been helpful. Okay, so I actually got it wrong. I had the wrong circuit breaker turned off, so that socket and that fridge socket are both on the same circuit. Obviously a later addition. Everything else in the house, including that for the toaster and the kettle, is wired off one 16 amp radial. How would you code that? Let me know in the comments. So I've managed to find the cooker circuit So we've got that there with a lovely plug on it, which I guess is the spark for the hob, and that's just plugged in with a nicely terminated bit of flex on there. So let's get a ZS reading on this circuit and see what we come up with. 10.14, so it is a bit lower because it's obviously a hefty cable. Functional test on these, that does seem to work, and the lights have gone off on the cooker, so that does work. This is a bit dodgy, so probably have to put a note about that. In fact, I might just redo it and then it's sorted. You can see they very nicely removed the cable clamp screws from this, so there's no cable clamping at all, and the exposed wires are coming out of the plug there. We see this quite a lot actually, but it's easy to rectify, so I usually just rewire the plug and then it's done. So I've put a new plug up on this now, so that's safe and done properly. By the way, that 16 amp radial also includes this washing machine tumble dryer. It includes that microwave over there, toaster, kettle. You can see how easily this place could be overloaded. So I turned the power back on and I started hearing this very loud noise coming from the loft, and I was like, what is going on? So here's one from my mate CJR plumber. How do you sort that out? Nice noisy. I know why. Basically, it's like the pump is vibrating and the casing of the pump is just rattling against this pipe. It's just been badly fitted basically. The whole thing needs to be rotated round so it's standing up, but it's not, it's standing on its side for some reason. I'm not going to go and loosen up these pipes because I'm not as confident as a plumber as Chris is, but I'm going to mention it to the agency and hopefully they can sort it out at least. But that is pretty dire, and the poor person who sleeps in a room below this, I feel very, very sorry for them. So I'm going to do an earth loop impedance test on this switch fuse connection unit for the heating system now and see what we've got. So I've got my incoming earth there. The neutral is down here, which is always a bit tricky, and the phase conductor is there. 10.5 ohms. Fine. Also just noticed this, which is pretty hilarious. So, you know, that is just rubbish. Absolutely rubbish. So for this loft light, we do have an earth here. We've got an OK ZS reading, so just going to need all tidying up really. It's just coming off the lighting circuit downstairs, so should be a fairly easy little job just to sort that out. So I've just tested this smoke alarm, which is the end of line, and I've got 11.55 ohms for earth loop impedance. So that's okay considering the dodgy ZE that we've got. So here we are inside the shed. I managed to get access to the main isolator, and actually it looks like the inside of David Savory's office in here. Full of cobwebs, and a madness poster pretty much sums it all up. But we do have a mini consumer unit here with some terrible wires coming out the top, spider's nest of a light switch, and some really badly clipped cables that have just got nails bent over to hold them in place. Although I suppose that does comply now with the avoidance of premature collapse of cabling. There's a nice connector block there with a bit of flex in connected to a batten holder, a lovely old light fitting up there in the eaves, and a beautiful socket here, perfectly IP rated, as you can see. So I'm just going to strike this building off and say needs full rewire. I will just check if there is power coming out to here, but I presume it's that twin and earth 2.5 that's coming out of the wall. In fact, you can see it here, look. It comes out of a switch fuse connection unit on the other side of the wall, and it comes up here at the other end through the wall, clips up and around, and goes into this light switch. So actually the consumer unit is redundant, it looks like, and instead they've just wired it straight into the light switch now. They've wired the socket off the light switch as well, and they've done a nice little neutral connection outside the switch here because they didn't have room to fit the neutral connection within the switch. And again, you know, excellent IP rating of the casing there. So all in all, a really lovely installation that any electrician would be proud of. I wonder where that cable goes through the wall. Let's have a look what's on the other side. Oh look, yet another shed. Let's see what's in here. Looks like it's sort of a feeble attempt to screw it shut. Oh, there we go. And we have another cave of wonders with a roof that's sagging, and that cable comes through from the other shed into this one, into this junction box here. Then it spurs off, lovely, spurs off three ways onto that light switch, which feeds this fluorescent light. See if it's actually working. I can't even turn the switch on. One comes down to this socket here. Not sure where the other one goes, to be honest. But it's all a hideous mess and needs to be condemned. So we'll just condemn that all, I think. What would you do? Let me know in the comments. Absolute disaster. Just an update, there is actually power out here because that switch fuse connection unit, when I turned it on and turned the light switch on, that switch comes on. So I'm going to just pull the fuse in that switch fuse connection unit because it doesn't look like anyone's actually using this shed anyway, apart from the lawnmower which is stored in here, which they probably plug into the house anyway. So I'm just going to disconnect all of this and then it's condemned because it's madness! So I think we're going to change the sign here from main isolator to mains isolated, and we're going to leave it that way until the building burns down. So I've just taken this blank plate off here just to see what was behind, and as I suspected, it's the cooker circuit. So basically the old cooker feed comes into here, and they used to have an isolator switch above the hob, which is not acceptable. So what they've done is just extended the cables down, and then they've put the cooker switch underneath it in the unit cupboard. So yeah, just screw connections. I mean, it's a bit tight in there, but not the end of the world. So I've put that blank plate back on now, but the biggest issue I can see with this is just the gaps here. It's just like, you know, not ideal because there's lots of grease and stuff coming up from the hob and getting into the back of the box. So it could be a little bit of a fire risk. So it could do with just sealing around there really with some silicone or something. Well, my predictions were correct. That place was a bit of a nightmare. So I've called UK Power Networks. They are going to come out as a matter of urgency to sort out the earth issue on the supply cable. But as I say, I think it's probably just a looped service issue that they've not clamped across between the two cables in the next property. So hopefully that'll be easy for them to fix. Otherwise it's going to be a new supply cable, which is a nightmare. But it is that old lead sheathed cable, so I wouldn't be surprised if it's corroded as well. Who knows?
Sorry, hang on. Hello?
Hi, it's Jordan here from Artisan Electrics. I was just seeing how you got on it.
Yeah, they're coming out to fix it tonight. I've temporarily bonded it over, and they're coming sending jointers out now to have a hole outside to do the proper job.
Brilliant. Okay, nice one.
So they're on supply again.
Yeah.
So they might take them off again later, but because the other option was a generator, and that's not really good with 4 people living there, is it?
No, absolutely not. Yeah. Okay, cool. I'll let the agents know because it's a rented place, so I'll just keep them up to date. And if you can get someone from UK Power Networks just to contact me once it's done and just update me, that'd be great.
Yeah, well, and there's going to be a hole out in the garden. There'll be a hole out in the garden.
Yeah. Okay, I'll let them know that as well.
And that will be put back at a later date.
Right.
That won't be tonight, I wouldn't have thought. Well, they might do it tonight. It depends what ground comes out.
Yeah. Okay.
Okay.
Lovely. Thanks a lot.
No worries. Cheers.
Bye.
Anyway, I wanted to go through all the paperwork on this video and show you me filling out all the EICR form online, but I think I'm going to have to do that in a part 2 because otherwise it's going to be a long video. There's just so many faults that I need to write down on this report. So I'm going to go back to the office now and write it up, and I'll film, do some screen grabs, filming the screen while I do that, and let me know in the comments if you'd like me to show a video filling out the report, if that'd be of interest to you. And if you enjoyed this video, hit a thumbs up and don't forget to subscribe. 70% of you watch my videos, you're not subscribed, and also 80% of you watch my videos, you are subscribed, but you haven't hit the notification bell. So if you're one of those, please just tap that notification bell, or if you haven't subscribed already, subscribe to the channel because there's more great content coming very soon. Thanks for watching and have a great day.